Welcome to Mastering Solutions. In this problem, we'll be discussing conservation of momentum and applying it to the squid to find the speed of the squid after it ejects the water to escape. So first off, let's draw a picture. You always want to do it whenever possible just because it's helpful to visualize what's going on. So let's draw a little squid here. All right, so we have our little squid, and they talk about how what the squid does is it ejects a bunch of water, and it helps it to propel it through the water to escape from a predator or whatever. So we're going to say that when the squid escapes, it's going to be going in the positive x direction. That's just how we're setting it for our problem, just so it's easier for us. So that means the squid will be going in the positive velocity when it goes that direction. And when the water comes out, it will be going obviously in the negative x direction. So it has a negative velocity. So now we can write the variables that we have since we have a better idea of what's going on here. So the mass of the squid is 1.5 kilograms. And they say initially it's at rest. So the initial velocity of the squid is 0 meters per second. Then they say that the mass of the water, water is equal to 0.1 kilograms. Everything's in SI units so far, which is great. And then when it ejects the water, the velocity of the water final is equal to 45 meters per second. So they say, what is the final velocity of the squid? So the final velocity of the squid is what we're looking for here. We know that the total momentum of the system is going to be equal to 0 because there's no outside forces acting on it. All it is the water and the squid. So we have the momentum of the squid plus the momentum of the water is equal to 0. So now we can move one of the variables over to the other side. It doesn't particularly matter which one. Let's just move the squid's momentum. Minus squid momentum. That goes away. And let's come over here now. So we have the momentum of the water is equal to the negative momentum of the squid. So when we break that up further, we have mv of the water, and that is final because the water was also at rest initially. So it also had initial velocity of 0 meters per second. So that whole thing will go away. It will be equal to the final velocity, so mass velocity of the squid, final. So now we can isolate the variable that we're looking for, which of course is the final velocity of the squid. So that's this guy right here. So we'll divide both sides of the equation by a negative mass of the squid. This will go away. And now we have a final equation of the final velocity of the squid is equal to the negative mass of the water divided by the mass of the squid, all multiplied by the velocity of the water final. Now don't allow this algebra here to confuse you at all. It's the exact same thing if you would have written it this way. We can write negative mv water final, all divided by the mass of the squid. So when you plug both of these into the calculator, you would find that the value that it kicks out is the exact same. Since we're dealing with multiplication and division, it's using the associative property. And so the value will be the same because the order doesn't matter. And so it's just representing algebraically what we're talking about. And this is the way that the book talks about it and that I feel works well for me and my brain. So now we can just plug the numbers into the equation. So the final velocity of the squid is equal to negative mass of the water, which we said is 0.1 kilograms, divided by the mass of the squid, which is 1.5 kilograms. Now we're going to multiply that by the final velocity of the water, which we said is a negative 45 meters per second. We got the negative here from our picture right there. So now when all of this gets multiplied together, it will give a positive velocity like we know it has to be in our picture. So now if we pull up our calculator, we have a negative 0.1 divided by a 1.5, and that's going to get multiplied by a negative 45 meters per second, which gives us the final velocity of the squid. Final is equal to 3 meters per second.